I shall discuss the performance of IC engine. Performance. Of IC engine. First, we have to know what is swept volume. 1. Swept volume, which is denoted by V suffix S. Now consider this is a cylinder and this is the piston which can move up to that. This piston can move up to that. Okay. Now this is the clearance volume. This is clearance volume. And this volume is total volume, that is up to that. This volume is total volume. Now if it is 0, then this will be V2 and up to that this will be V1. Okay, because if I draw the diagram, then we know this is a suction process and after that this one is reached and then the compression process, it will move up to that. During the compression process this piston will move up to that. So this is the 2 and after that combustion, expansion and heat rejection process. So if this is 0, then this volume is V1 because this is 1 point and this volume which is up to that, this volume is V2. So up to this volume, up to 1, this volume is V1, that is the total volume. This V1 is the total volume and V2 is the clearance volume. So I can write this V1 is total volume and V2 is clearance volume. Okay, and this volume from this to this is called swept volume. This is swept volume and this swept volume will be V1 minus V2. This is the swept volume. So the swept volume is the volume which is swepted during the movement of the piston. I can write it is the volume swepted by the piston during stroke. Stroke means the movement. Okay, this L, distance traveled by this piston, is the stroke. Okay, that is the volume of cylinder from this is BDC and this is TDC, from BDC to TDC. So this volume which is swept from DC to TDC is called the swept volume. So if we minus the total volume with clearance volume, then we can get the swept volume, is not it? That is V1, this total volume, minus V2 is the swept volume. Vs, you can write this is V1 minus V2. Okay. Now next is mean effective pressure. Mean effective pressure, which is denoted by MEP, mean effective pressure. It is the ratio between work done and swept volume. What is work done? This is the work done. Okay, this area is the work done. Okay, work done. So I can write it is the ratio of work done, that is WD, work done, with swept volume. Swept volume. Swept volume is denoted by V suffix S. So I can write MEP equals to work done by V suffix S equals to work done by V1 minus V2. As Vs is V1 minus V2, I have written this V1 minus V2 here. Now 3. Piston speed. V suffix P, that is the piston speed. The speed of the piston. This is the speed of the piston. Let crank rotation or speed is in RPM. This crank is rotating in n RPM. Consider this is the cylinder and this is the piston. The rotational speed of this crank is n RPM. That means the crank can rotate in n RPM. That is, number of rotation is n in 1 minute. N rotation in 1 minute. Okay. And I am considering and stroke length is L. This stroke length is L. What is stroke length? This is stroke length, that is L. Okay. So what we can write? We know one rotation of crank piston moves 2L distance for 2-stroke or 4-stroke, whatever. For one rotation of this crank, the piston will move 2L distance. I have written in previous class is that one rotation of crank, the piston will move 2L distance, and for 4-stroke engine, it is also for 4-stroke engine, for 2-stroke engine, this is also one rotation of crank, the piston will moves 12 distance. Whatever it is, 2-stroke or 4-stroke engine, this will be the same. You can see this is for 4-stroke engine, this is 12 distance for one rotation of the crank. Similarly for 2-stroke engine, this is also one rotation of crank, the piston moves 12 distance. Okay, now I can write, therefore n rotation of crank piston moves 2ln distance, that is one rotation 2l, n rotation is 2ln distance, and as this n rotation is produced with 1 minute, so I can write 2ln distance per minute. So I can write, so Vp piston speed is 2ln distance per minute, which is equals to 2ln by 60 distance per second. Now I am going for indicated power. Indicated power. What is indicated power? It is denoted by IP. This is IP, indicated power. IP is a power produced within the engine cylinder. Here this is the cylinder and this is the piston. This IP produced at this cylinder. The power produced is IP. The power which is produced in the cylinder due to the combustion of the fuel, this power is produced, and this power is the IP. Okay, indicated power. Now this is the crank. As work done equals to MEP, mean effective pressure, into P suffix s, that is swept volume. I have already discussed that here. Mean effective pressure, this mean effective pressure equals to work done by swept volume. So work done equals to mean effective pressure into sweat volume. So I can write what is work done, that is the power here. So I can write IP indicated power equals to indicated mean effective pressure, that is pressure which is produced by indicated power. This pressure, mean effective pressure which is produced by indicated power. I can write it is IMEP into Vs, where IMEP is indicated mean effective pressure. This mean effective pressure is produced due to indicated power. Same. So I can write this one is IMEP into sweat volume. What is sweat volume? Sweat volume is the volume in this cylinder up to BDC to TDC. So if this area of this piston is A, then I can write the volume swifted is A into L, and due to the rotation of this crank in n RPM, then I can write this sweat volume in 1 minute is ALN into N, and this amount of sweat volume is produced, the volume is sweated in 1 minute because N is the RPM. So I can write this is the watt per minute, where N is speed of crank in RPM, and A is area of piston. Now this equals to, I can write IMEP into ALN by 60. To converting this minute into second, we have to divide the 60, and to converting this watt into kilowatt, we have to multiply with 1000. That will be, the unit will be kilowatt per second, and this value we can write IMEP ALN by 60 into 1000. This is for 2-stroke engine. This IP value is this, and this is for 2-stroke engine. Now what will be for 4-stroke engine? This value will be IMEP ALN 60 into 1000 into divided by 2, because for 4-stroke engine the power is half. The power produced for 4-stroke engine is half than the 2-stroke engine. So I have divided this by 2. Okay. So this is for 4-stroke engine. Okay. Now this is indicated power. We have to find for brake power. What is brake power? Brake power, which is denoted by BP. BP is, brake power is power available in crank. Consider this is the cylinder and this is the piston and this is the crank. Okay. Now power produced in this cylinder is IP, but this amount of power will not reach with same amount to the crank, because there is the relative motion in various sections. So some amount of power will lost due to friction. This causes some frictional loss will be there, and after that the percentage of power will reach to the crank. So this power available at the crank is BP, that is brake power. All the power is not same because there is some friction in this link. Okay, so after the losing of this power, final power reached to this crank, and this value is often is less than the IP, and this power after all types of rotational motion, this final power available in this crank is the BP. Okay, now I can write same as indicated power, BP equals to, as we written for indicated power, similarly I can write BMEP LAN 60 into 1000 for force for 2-stroke engine, where BMEP is brake mean effective pressure, and this value will be BMEP LAN by 60 into 1000 into 2 for 4-stroke engine. Okay, as for 4-stroke engine power is less than the 2-stroke engine. Okay, now mechanical efficiency. 6 is mechanical efficiency, which is denoted by eta m. It is the ratio of BP and IP. Okay, so eta m equals to BP by IP. 7 is friction power, that is denoted by FP. The Frictional power is the power. You can see this amount of power is lost, that is by friction. Okay, so you can see that this IP is reduced to BP by the friction. So the power lost by the friction is the frictional power. Okay, so I can write this is the power lost. So the FP is the power losses due to friction from cylinder to crank. That is FP equals to IP minus BP. This amount of change of power is the friction power. That is the power which is lost by the friction. Okay, now 8. The thermal efficiency that is eta th suffix th. It is the ratio of power that may be BP or IP. This is the power, and BP may be BP or IP with heat input. Is the ratio between power produced with heat input. Okay, so eta th equals to IP or BP by heat input. This heat is produced due to the combustion of the fuel in the cylinder. Okay, now you can write A, that is brake thermal efficiency. It is generally two types. One is brake thermal efficiency, that is denoted by eta thermal th brake equals to BP by heat input. Similarly, indicator thermal efficiency that is eta thermal indicated equals to IP by heat input. Okay, now as mechanical efficiency eta m equals to BP by IP, I can write this is Bp by heat input, Ip by heat input. This value will be, so Bp by heat input, that is eta Th break thermal efficiency, and this one is indicated thermal efficiency. Okay. Next is relative efficiency 9. Which is denoted by eta REL, suffix REL, that is relative efficiency. It is most important. It is the ratio of indicated thermal efficiency with air standard efficiency. Air standard efficiency is the efficiency which is done in Otto cycle and diesel cycle. So it's written as eta REL, relative efficiency, equals to indicated thermal efficiency eta thermal indicated divided by air standard efficiency. Okay. Now, what is air standard efficiency? The air standard efficiency, writing for Otto cycle, that is Otto equals to 1 minus 1 by Rk gamma minus 1. Okay. This is the power gamma minus 1, and the air standard efficiency for diesel cycle noted by eta diesel equals to 1 minus 1 by Rk gamma minus 1 into at the top Rc gamma minus 1, and this value Rc minus 1. Okay. Now you have to remember this formula for Otto cycle efficiency and diesel cycle efficiency, which is the air standard efficiency. Okay, and we can write this is only eta, this is air standard efficiency. Okay, next you can see what is this Rk and Rc, where Rk is compression ratio, compression ratio, that is V1 by V2. What is V1 by V2? Consider this is the Otto cycle. This is 1, this is 2, this is 3, this is 4. For Otto cycle, this V1 is this value is V1 and this is the V2. Okay, this value, the volume at this point 2, volume at this point 1, that is V1. So if we make the ratio, then compression ratio is obtained, where RC is cutoff ratio. It is of cutoff ratio, which is V3 by V2. It is obtained only in diesel cycle. That is, diesel cycle is look like that. This is V1, this is V2, this 2, and this is V3 and V4. So this value is V3 and this value is V1 and this value is V2. So the ratio between V1 and for V3 and V2 is the cutoff ratio. This is V2. So V3 by V2 is the cutoff ratio. Next is overall efficiency. 10 is overall efficiency, which is denoted by eta suffix O. Overall, it is the same as brake thermal efficiency. Brake thermal efficiency, which is BP by heat input. 11 is heat rate, which is denoted by HR. This equals to the amount of heat is required to produce one unit of power. Okay, that is heat supply. This is the amount of heat which is supplied with power produced. Produce 1 unit of power. So to produce 1 unit of power, how much heat is required? That is the heat rate. It is the mass of fuel is mf into calorific value, that is the same as HV divided by power produced, where m suffix is mass of fuel used and HV is fuel heating value. Now we can write that HR equals to this power produced is in kilowatt hour. Okay, so I can write m suffix a into hv by power in kilowatt second. Then we have to multiply, we have convert this hour into second, so we have to multiply with 3600. So I can write this equals to 3600 divided by power by this value is heat supply. So this is heat supply, this value is heat supply, so I can write 3600 divided by heat supply is thermal efficiency. Already we know this is power by heat supply, this power by heat supply is thermal efficiency, so I have written is this is 3600 by thermal efficiency. So I can write this, that is HR is inversely proportional with the thermal efficiency. Now 12, it is the specific fuel consumption. Specific fuel consumption, which is denoted by SFC. What is fuel consumption? Fuel consumption is m suffix f's, the mass of fuel used, and specific fuel consumption is the amount of mass is required to produce 1 unit of power. So this is the amount of fuel is required to produce 1 unit of power. So SFC equals to the value of mf by power.